So, I'm Dr. Lutzmir, Associate Professor in the Department of Computer Science and Engineering. I'm going to take the topic Google App Engine for the subject cloud computing. So, Google App Engine. So, it does one thing well. It's running web applications, simple application configuration. It's scalable and secure. So, these are the features. This app engine handles HTTPS, Hypertext Transfer Protocol request, nothing else. So how to think a remote procedure call? The request is in and you will be processing the response out. It works well for the web and Ajax and also for other services. So application configuration is dead simple. No performance tuning is required. So everything is built to scale. It's infinite number of apps can be implemented. Number of requests, any number of requests it can be able to process. Storage capacity is more. Application programming interface are simple. So how the architecture will look like? So stateless APIs, URL fetch, you can send the mail, images. Stateful APIs, memory cache will be there. So Python VM process, you can have the standard libraries and applications. Request and response is there. So HTTP transfer protocol, the data store is there. So you can have any number of web applications. There's a stateful APIs that is related to the memory cache and the data store. The stateless application programming interface. So this is similar to the Python VM process is the only thing that differs. So scaling, so low usage application, many application per physical host is there. High usage application, multiple physical host per application. Stateless APIs are trivial to replicate. You cannot able to replicate it. So memory cache is trivial to share. It cannot be able to share because it's the heart of the entire architecture. The data store built on a big table, so designed to scale well. So abstraction on top of the big table. So API is influenced by scalability. Any number of systems can be added. Any number of requests can be given. So no joins. Recommendations. It will denormalize the schema. Pre-compute the joins. Security. It prevent the bad guys. That is a security. So masqueraders cannot be able to get into the application. So constrain direct OS functionality. No processes. No threads. No dynamic library binding. So no sockets, so URL fetch is not possible. You cannot able to write files. So use data store. So disallow unsafe Python extension like C types. So limited resource usage. It can limit 1000 files per application. So each at most 1 MB. So hard time limit of 10 seconds per request. Most requests are less than 300 milliseconds CPU time. Hard limit of 1 MB on request or response size. API call size, quota system for number of requests, so API calls, emails sent, etc. So Linux, why not LAMP? LAMP is Linux, Apache, MySQL, Python, Perl, PHP, Ruby. So LAMP is the industry standard. So but management is a hassle. It's facing its own problem. Configuration and tuning, backup and recovery, disk space management, hardware failures, system crashes, software updates, security patches, log rotation, cron jobs. So redesign is needed once your database exceeds one box. Automatic scaling to application needs. You don't need to configure your resource needs. One CPU can handle many requests per second. So one process per app, many apps per CPUs. So creating new process is a matter of cloning the generic model. The process hangs around to handle many requests. Eventually, old processes are killed. So busy apps get assigned to multiple CPUs as long as CPUs are available. So preserving fairness through quotas. If everything an app does is limited by the quotas. So request count, bandwidth used, CPU usage, and data store call count. So disk space is required, emails is sent, even errors. If you run out of quota, that particular operation is blocked. So raising an exception for a while, 10 minutes until replenishment. Free quotas are tuned so that well-written app can survive a moderate slash dotting. So the point of quotas is to be able to support a very large number of small apps. Large apps need raised quotas. So currently this is a manual process. So hierarchical data store. So entities have a kind, a key and properties. Entity is a record or a Python dictionary or a Python class instance. Key is a structured foreign data, includes kind. Kind table is Python class. Property common or field has a type, dynamically typed. Key has either ID or name. Paths define entity groups which limits transactions. Indexes properties are automatically indexed by type plus value. This supports and on property equality. The equality should be less than or equal to greater than. Index building has to scan all entities